We've reached the point in our study of logic called the propositional logic or the statement logic, where we're going to assess arguments using truth tables, and we're going to use truth tables to ferret out the different logical characteristics that statements, individual statements, or groups of statements can have. So what you see here is a truth table. Usually you'll just see the two wider lines. The skinny lines are there just for me to be able to line things up. And this truth table we're going to use to capture something you already know. What we're going to use the truth tables for is pretty much something that you've already mastered. We're just going to find a new way of expressing something that you already know. So look at this first claim here. Obama is president and Biden is vice president. In the year 2015, Obama is president is a true claim, and Biden is vice president is a true claim. So if someone were to say to you, Obama is president and Biden is vice president, you'd say, well, that's true. And it's true because the left side of the and claim is true, and the right side of the and claim is true. Both parts are true. And an and claim is basically saying that one thing is true and this other thing is true also. That the left side is true and the right side is true also. So whenever any part of an and claim is false, since an and claim is saying both parts are true, if one part is false, the whole and claim is false. And that's something you already know. Look at this second claim. Suppose someone were to say to you, Obama is president and Clinton is vice president. Well, the claim Clinton is vice president is false. So if someone were to say Obama is president and Clinton is vice president, you'd say, no, that's wrong. That's false. Clinton isn't vice president. And that's what we've captured here. Look at the third claim. Suppose someone were to say Romney is president and Biden is vice president, but at this time, the claim Romney is president is false, and the claim Biden is vice president is true. If someone were to utter that whole claim, you would say it's false, because Romney isn't president. And this last one, Romney is president is false and Clinton is vice president is false. And if someone were to say to you, Romney is president and Clinton is vice president, you would say that's false, primarily because the first statement is false and the second statement is false. These are all the different ways in which a conjunction, an and claim, can be true or false, with both parts being true, with both parts being false, with one part being true and the other part being false. And this is something that you already know. What we're going to do is we're going to take this and express it in a more in a truncated, summary fashion, and we'll do so in a way that'll let us test arguments for validity using a sort of mechanical approach, where we won't have to just eyeball them and ask ourselves, assuming the premises are true, would the conclusion have to be true? We'll be able to construct a truth table for an argument and go line by line and use a mechanical procedure and assess whether the argument is valid or invalid. So the first claim, Obama is president and Biden is vice president. We could represent that like this. Let's allow O to stand for Obama is president, and let's let B stand for Biden is vice president. And currently, the claim Obama is president is true, and the claim Biden is vice president is true. And what happens when both parts are true? Well, that whole claim, Obama is president and Biden is vice president, is true. So in this truth table down here, this partial truth table, we've captured what was claimed in our first sentence, that Obama is president and Biden is vice president, but we've captured it in a more truncated, symbolized way. Or take our second claim, Obama is president and Clinton is vice president. Again, using O for Obama is president, that would be true. And using C for Clinton is vice president, that would be false. So the whole claim, Obama is president and Clinton is vice president, is false. We're using this second partial truth table to capture or represent our second sentence and the fact that it's false. So truth tables are going to allow us to find a way to summarize all these different ways in which an and statement can be true or false without having to write out all the sentences. And the truth tables will allow us to figure out when a statement is true or false using an and when it's talking about other things than who's currently the president and who's currently vice president. So let's look at the truth table for a conjunction, for an and claim. We'll put on the right side an and claim. You will notice that we use lowercase letters. Lowercase letters are variables, and they do something different than what the uppercase letters do. Uppercase letters actually stand for particular statements. They symbolize a particular statement. So we don't use capital letters unless we have a particular statement in mind that the capital letter is supposed to stand for. Lowercase letters are variables, and they don't stand for anything. They're just placeholders. So in this truth table, when it says P and Q, what it's really telling us is that there's something in this spot here, and there's something in that spot there. And that'll make more sense as we go along. Why saying that these are variables that are just placeholders is going to be important for us. So there are two parts to an and claim. We have the P part and the Q part. Now over here on the left side, we want to capture every possible arrangement of truth values, every way in which P and Q can be true and false. One obvious way is for both of them to be true. Or perhaps P could be true and Q false. Or P could be false while Q is true. Or both could be false. There's actually a formula for filling out this truth table, which we'll talk about. But for any of our truth tables, for and truth table, for the or truth table, if then and if and only if, it's always going to set up like this. And so if you want to note the pattern, on the left side here, it does the top two are T's and the bottom two are F's. And then this last column over here is always just alternating T, F, T, F. So left side, two in a row, two T's, two F's. Right side, alternating T, F, T, F. Now that we have all the possible arrangement of truth values, all the ways in which P and Q can be true or false, we'll see what the outcome is. So what happens when we have an and claim and both parts of the and claim are true? Well, then the whole thing is true. That's what we saw with Obama is president and Biden is vice president. Because an and claim is saying, here are two things and both of them are true. Not just one, but both the P and the Q are true. But if that's what an and claim is saying, then there's only going to be one case in which it's true, when both parts of an and claim are true. The rest of the time, an and claim is going to be false. When either P is false, or Q is false, or when they are both false. So this is the truth table for a conjunction. Anytime we assess the truth value of a conjunction, we sort of lay this truth table over it, and it tells us how to figure out whether the conjunctive statement is true or false. Think of the truth table as like a truth-generating machine. Over here on the left, we have our inputs into the machine. And over here on the right, we have the output. So given the input of true and true, we get the output true. Or given the input of true and false, we get the output of false. So to remember this truth table, you really only have to remember one line of it, because there's only one case in which it's true. The rest of the time it's false. It's only the first line in which both parts are true that an and statement is true. So that's the one line you need to focus on, the one you need to remember. Once you remember that, then you can infer what the rest of the truth table looks like. You just fill it with F's for the rest. Let's see how this works in actual practice. Here is a claim. It says this day of the month is a prime number, and tomorrow is a number divisible by 4. Now we could make this claim on different days of the month, and depending on what day of the month it is, it might come out true, it might come out false. So let's look at the first one. Suppose we make the claim this day of the month is a prime number and tomorrow is a number divisible by 4 when it's February 7th. So the first part of that and claim is true. This day of the month is a prime number. 7 is a prime number. Let's look at the second part. And tomorrow is a number divisible by 4. So the next day would be February 8th, and that is a number divisible by 4. So both parts are true. So let's represent this in our truth table. Let's use P to represent this day of the month as a prime number, and use D to represent and tomorrow is a number divisible by 4. In our first case, both parts are true. And the truth table for a conjunction says when both parts are true, the whole statement is true. But what about a case in which one part is false? Let's look at the next one. Suppose it's February 13th, and you say this day of the month is a prime number, and tomorrow is a number divisible by 4. Okay, this day of the month is a prime number. Well, if it's the 13th, that is a prime number. Prime number is a number that's divisible by 1 or by itself. So that first part's true. But what about the second part? And tomorrow is a number divisible by 4. The next day will be February 14th, but 14 is not divisible by 4, so that claim is false. So we have true and false, and that's going to give us false. When we represent the truth values over here on the left side, they are, in a sense, there in the main part of the truth table. We usually don't write them because it just puts too much stuff out there for us to keep track of. But that's what it's really saying. When it says this is true and that's true, well, there's the true there and there's the true there. Now let's apply that claim to another day, February 15th. So suppose it's the 15th of February, and you say this day of the month is a prime number, and tomorrow is a number divisible by 4. Since it's the 15th, well, that's not a prime number, so that claim would be false. Tomorrow is a number divisible by 4. Tomorrow would be the 16th, and so that is divisible by 4, and that would be true. But an and claim is saying both parts are true. It's saying the P is true and the D is true. And if one part is false, the whole thing is false. And finally, suppose we make the claim on February 18th. We say on that date, this day of the month is a prime number, and tomorrow is a number divisible by 4. Well, on the 18th, that's not a prime number. So that claim would be false. And tomorrow is a number divisible by 4. Well, that would be the 19th. And it's not divisible by 4, so that part would be false as well. When both parts are false, obviously the whole thing is false. So once again, there's only one case in which an and claim is true. The rest of the time it's false. And it's one false component that destroys an entire and claim. All you need is one false component, and the whole thing is false. To sum up then, the truth table for conjunction gives us all the instances in which a conjunctive statement is true, and all the instances in which a conjunctive statement is false. So with the conjunction truth table, we set it up first by plugging in variables that represent spaces where statements will eventually go, or symbolized statements. Some of those may be quite complicated. So that's saying here that there is something on the left side of this truth table, or this conjunctive claim, and there is something on the right side. And we want to pull those out, those two components of the conjunction, and represent them over here individually, P and Q. And then on the left side, we want to capture all the possible ways in which P or Q can be true or false. So they could both be true, or P could be true and Q could be false, or P could be false and Q could be true, and finally, both could be false. On the truth table part, we want to express what happens when, let's say, P is true and Q is true. Well, then the conjunction is true. What happens when P is true and Q is false? The conjunction is false. What happens when P is false and Q is true? The conjunction is still false. And what happens when they're both false? P is false and Q is false. The conjunction is false. Now there's the way we set this up. On this left side here, we give all the possible arrangements of the truth values, all the possible ways in which P and Q can be true or false. And invisibly, there is the truth values here. That is, this T and this T shows up here and here, and this T and this F show up here. But that gets pretty complicated. Now our eyes have to focus on too many things at once, and it's easy to get lost when you have all those truth values up there. And so instead of writing out all of those truth values underneath the P and Q on the right side of the truth table, we just represent them on the left side with true and true, true and false, false and true, and false and false. That way, this side over here looks a little cleaner, and it's easier to identify when a conjunction is true and when it's false. And as you recall, there's only one case in which a conjunction is true. That's when both parts of the conjunction are true. The rest of the time it's false. So that's really the only line of the truth table you need to memorize, that it's only true in one case, and then you can infer the rest. Now we'll look at disjunctive claims, claims that use an or. And there are two ways of expressing an or. I should say, two types of or claims. There is what is called the exclusive or and the inclusive or. Often when we use or make an or claim, we have the exclusive or in mind, which is we're saying it's one thing or the other, but not both. So if I say I'm going to buy either a one-story house or a three-story house, and I buy the one-story house, you can infer I didn't buy the three-story house because it's either one or the other, but not both. Or if your instructor says to you, either you rewrite your paper or you will get a D on that paper, it's either one or the other, but not both. Either rewrite it or get a D, but it's not rewrite it and get the D. There's also the inclusive or, and the inclusive or tells us that it's one or the other or both. So suppose you get a nice job offer from a company in another state, and they say, if you take the job, either we'll give you a car or we'll give you a house to live in. And when you arrive at your job, you find that they've been especially nice and they've given you the car and the house. It's not that they lied to you. They said either one or the other, but it could have been both, and they decided to give you both. Or if Carol's parents say that if she's going to live at home, then either she has to go to college or get a job. They're not going to be terribly upset if she goes to college and gets a job. So that's the inclusive or. And when we represent or claims in a truth table, we're going to be using the inclusive or, and we'll be able to represent the exclusive or with a longer, more complicated truth table. So an or claim is saying there's either one thing that's true or this other thing that's true, or both of them are true. So look at our first statement here. Either Mankato is in Minnesota or Des Moines is in Iowa. Both parts are true. Mankato is in Minnesota, Des Moines is in Iowa. Well, if someone were to say that to you, if they were to say either Mankato is in Minnesota or Des Moines is in Iowa, and they were using the or in the inclusive sense, you'd say, well, that's true. What if they were to say instead that either Mankato is in Minnesota or St. Paul is in Iowa? Well, in that case, the first thing they said would be true, but the second thing would be false. But they got one thing right, and they're saying it's either one or the other, or both. So what they say is true. You'd say, yeah, that's true, because Mankato is in Minnesota. Or suppose they said either Des Moines is in Minnesota or Des Moines is in Iowa. There they got the first part wrong, but they got the second part right. And the or claim is just saying it's either one or the other or both. And since it's not this one, but it is the other, the whole thing is true. And suppose someone said either Abraham Lincoln was born in 1999 or in 1998. You would say that claim is false. Why? Because it's neither. It's neither one or the other. Both parts are false. So this gives us the cases in which an inclusive or claim is true or false. And just like with the conjunction, we can represent that with a truth table. So let's look at our second claim here. Either Mankato is in Minnesota or St. Paul's in Iowa. We can use M to represent Mankato is in Minnesota, S to represent St. Paul's in Iowa, and here's the claim symbolized. And what we can do is we can represent out here to the left the case, whether it's true or false in this case. So it is true that Mankato is in Minnesota, so we put true underneath the M, and it is false that St. Paul's in Iowa, so we put false there. But when a disjunctive claim has one true component, because it's saying it's either one or the other or both, the whole thing is true. And it's this truth that you already know about when an inclusive or claim is true is something we're going to capture with the disjunctive truth table. So we'll start out the same way as we did with the conjunctive truth table, but instead of using an and or a dot, we're going to use a v, an or. We still have the same variables, p or q, and those variables again are just placeholders. They tell us there's something in this spot here and there's something in that spot there. And now we want to represent those parts of an or claim out to the left side of the truth table, and then on this left side give all the cases in which they are true or false. So in one case they could both be true. In one case P could be true and Q could be false. In another case P could be false and Q true. And finally, one option is that they're both false. And if you recall, there's a pattern to this where starting with the left side, you do pairs. So true, true, then false, false. And then you go to the last column, the right side, and it's always alternating. True, false, true, false. So now that we have our truth table set up, we can write in or express all the cases in which an or claim is true or which an or claim is false. So if both parts are true, the or claim is true, because an or claim is saying it's one or the other or both. If at least one part is true, the or claim is true. The only time it's false is when both parts are false. So it's very easy to make an or claim true. You're sort of hedging your bet when you make an or claim. You're not committing yourself to much. You're just saying, well, it's either one or the other or maybe both. Unlike an and claim, where you're committing yourself to a lot. You're saying both of these are true. It's this one and this other claim. So since there's only one case in which a disjunction is false, that's the one we need to memorize, and then we can infer everything else. If we remember that there's only one case in which a disjunction is false, then we'll know that any time we have a disjunctive statement and it has at least one true component, the whole thing is true.